But I got here a few resistors today. All of these are resistors. This little electronic component. These are of different values. So this is a 1 kilo ohm resistor. This is a 220 ohm resistor. So what is resistor? Resistor is basically something that can resist the flow of electricity or electric current. We use this a lot in electronic circuits like this. You can see so many resistors. This is a random printed circuit board that I found. Yeah, there are so many resistors you can see, and you probably noticed these those little color bands around the resistor, which basically indicates the value of the resistor. We can read, this is like a color code, so we can read the value of the particular resistance from this color code. For example, the one that you notice, this one over there, this is like red, and the last band is like, it's a golden colored band. So red stands for number 2, so it's like 2 2, and the last one, the last is not, is 2. That's called a multiplier, which we should be multiplying by the power of 10. So this is like 2 2 2, but which means 2 2 22, and the last one is the power of 10, which is 10 square, which is 100. So it is 2.2 kilo ohm or 2200 ohm. And the gold band indicates the tolerance, like how much the value of the resistance can be shift from the value that we just read. Meaning it is 2.2 kilo ohm, and there could be an error. The gold indicate like plus or minus 5%. So there could be an error of 5%. And if you look at this one, this like 2, the red indicate 2, again the red that indicate 2, and the next one 0, black is for 0. Then the last one is the multiplier, 10's multiplier, that is 10 to the power of 0, which is 1. So this is 220 multiplied 10 to the power of 1, which is 220 ohm. And the last brown indicate it has like 1% shift from the value that we read. That's possible. That's the tolerance, like 1%. It could be like it's 220 ohm, but it can be maybe 220 ohm plus 1% of 220 ohm, or 220 ohm maybe a little less than 1% than 220 ohm. And this is also a resistor. This is called potentiometer. We will talk about it later. If you look at this, it says a 10K over there, which means 10 kilo ohm potentiometer. That is the maximum resistance of this potentiometer. When we talk about the color code, there's an easy way to remember the color code, which is something that I learned in my high school, which is, I'll just write it down. It is like, it goes like this: B B R O Y G B like that. Like that. This is the color code. To remember easily, we just say like this, like BB Roy of Great Britain has a very good wife. That is an easy way to remember this, the order of this color. And in order to read a color code of a particular resistor like this, we number these letters from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you look at this, the first is red. The first color band is red. So which is red is 2. The next one is also red, which is 2. And the next one is black, which is 0. And the next one is also black. So that's the multiplier. The last one is multiplier. I mean the one just before the tolerance. That is 10 to the power of 0. And the last one is brown. So you have to remember the brown stands for 1% tolerance, and gold band is for 5%, and silver is for 10%, I guess. So the resistance of this particular resistor is 220 ohm. So these colors are before black, brown, red, orange, yellow, green, blue, violet, gray, and white. That's how the colors are recorded. Then if you look at another resistor like this one, this has I don't know if you guys can see it clearly, which is basically brown, which is 1, black 0, then again black, which is 0, then again brown, which is 1, which is 10 to the power of 1, and the last one is for the tolerance, which is plus or minus 1%. Oops, that's my multimeter. So for this resistance, it is 1000 ohm plus or minus 1%. Okay, that's how we read the color code. So now what I want to show you some resistors in different configuration, like in how they act in a circuit. So I have 3 1 kilo ohm resistors here. All of these are 1. Okay, I'm just pulling off. This is a 220 ohm resistors. I'm not using that. I'm just putting it away. So if you notice, I connected these 3 1 kilo ohm resistor in series. I connected the second resistor to the end of the first resistor, then the third resistor to the end of the second resistor. So it's in series. Let's measure the resistance of each resistance. I have this multimeter over here. Says now my multimeter showing 1 kilo ohm first resistor, and if I touch the second one, that is also showing 1 kilo ohm, and the third one 1 kilo ohm, 1.001. So a little greater than 1 ohm. Okay, so let's see what happens when we connect 2 resistors together. This is 1 kilo ohm, this is 1 kilo ohm, and it's connected in series. So the total resistance of the first 2 resistors is 2 kilo ohm. So 1 kilo ohm and 1 kilo ohm, 2 kilo ohm. Then if you measure the three resistor altogether, it is 3 kilo ohm. So what we learn, like if we connect three resistors in series, the total resistance would be the sum of each resistors. So three 1k ohm resistors in series, that is 3 kilo ohm in total. What if I connect two resistors in parallel? So connected like two resistors in parallel, each of them are 1 kilo ohm and 1 kilo ohm. Let's see what's the total effective resistance of the circuit. If I'm using a multimeter and I measure the resistance between this combination of the two resistors, you can see it's like half a kilo ohm or 500 ohm. So the resistance halved. Let's connect one more. So I have three resistors in parallel. Let's check what happens to the total resistance. You can see the resistance decreased further. Now it is, oops, it is 0.333 kilo ohm or 333 ohms. So when we connect resistors in parallel, the effective resistance will be decreased, and if it is in series, it will be increased. So I just want to show you a little bit of calculation, not calculation, some formulas to calculate the effective resistance of the circuit. That one. So imagine I have the first resistor here. This is the symbol for the resistor. This is the symbol that we use in North America, and this is the international symbol for the resistor. Just a box with two pins, two leads. Okay, so this is the first resistor, and I'm connecting another resistance to the first resistor. That's the second one, and this is the third one. So these are like R1, R2, R3, three resistors in series. So if three resistors in series, the effective resistance will be R1 plus R2 plus R3. Let's say the total resistance R is equal to R1 plus R2 plus R3. So we basically add all resistors together, the resistance together. This is imagine 1k, 1k, 1 kilo ohm. Then the total resistance will be 3 kilo ohm. And if we connect few resistors in series, see, this is the first resistor. I'm connecting another resistor to that in parallel, like that. Then I connected one more resistor in parallel to that. So this is a R1, R2, R3. So if the resistors are in parallel, the effective resistance, say R, which is the total resistance of the circuit, will be, we can get the total resistance of the circuit from the equation 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. From this equation we can find R. So we did, like just before in the breadboard, we connected 3 resistors, 1 kilo ohm resistors in parallel. So, and we got 0.333 kilo ohm. That's what our multimeter read. How did we get that 0.333? See, the effective resistance is 1 by R. The first resistance was R1 was 1 kilo ohm, so 1 kilo ohm, which is 1000 ohm. The second one was 1000 ohm. The third one 1000 ohm, which is equal to 3 divided by 1000, which is 1 by R equal to 1000 divided by 3, which is 333. I guess I'm right. That's how we calculate. Now, how did this formula came? We know if that's from the Ohm's law, by the way. The Ohm's law states that the voltage across a resistor or a conductor is directly proportional to the current flowing through the conductor, and the constant of proportionality is called a resistance. So V is equal to R into I. So that's Ohm's law. This voltage across a conductor is directly proportional to the current flowing through the conductor. If we look at here, if we are applying a voltage V across this combination of resistors, this voltage will be same all across these resistors. But let's say I is the current flowing. This I will be divided into 3 parts to each resistor. Say I1 flowing this way, I2 flowing this way, I3 is flowing through the third resistor. I is I1 plus I2 plus I3. I should be sum of each current flowing through each resistor, I1 plus I2 plus I3. But we know the voltage across each resistor is same. So we know from the Ohm's law V is equal to I R, which means I is equal to V divided by R. So I is equal to V divided by R. I1 is equal to V divided by R1 plus I2 is equal to V divided by R2. I3 is equal to V divided by R3. We can cut off these V's on both sides. Then 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that's how the resistors work in series and in parallel, which is not a very complicated formula or anything. So if few resistors are connected in series, the effective resistance will be the sum of each resistors, and if it is connected in parallel, the effective resistance will be decreased. Then I told you guys I will talk about a little bit about this. This is basically a potentiometer. It's called a potentiometer. the use of this thing is we can vary the resistance value of the resistor. So basically this device is a resistor just like that, but you can see like a third pin in the middle. So this is this first pin and this is the second pin, and there's a third pin in the middle which is like a slider. So you can move this the contact from this pin, and so we can vary the resistance. So it's like a 10K. If you move, like turn this all the way to the left, the resistance between this first pin and the second pin would be 0. And when we move to the further to the right, it goes from 0 to 10 kilo ohm. So the position of the slider depends. The resistance between this point and that point depends on the position of the slider inside this potentiometer. I can't show you that, but that's how it works. If I turn all the way to the right, the resistance between this point, this pin and that pin will be 10 kilo ohm. If I put it in the middle, it will be 5 kilo ohm. And if I go all the way to the left, the resistance would be 0. So this is just a resistor that we can able to change the value as we want. All right, that's it for today. I will be talking about voltage divider on the next video. Voltage divider, basically some resistors together and we apply a voltage, then we will be able to we will be able to divide the voltage into different parts. So it's basically like this circuit, but we will be connecting to the negative and the positive rail of the breadboard, and we'll be connecting to the battery, and we will be checking the voltage across each resistor. And also I will show how to divide voltage using this little potentiometer. You can see something is sliding inside. Alright, that's all for now, guys. Thanks for watching. If you learned something from this video, give me a thumbs up and subscribe to my channel. I will be making more videos in the coming days. Thank you.